My name is Ali Vanderveld. I'm a senior staff data scientist at Wayfair, and I'm going to talk to you today about some work that we've been doing for optimizing recommendation systems when you have competing business objectives. So here's just a quick agenda of what I will cover today. First, I'm going to talk about what you might call traditional recommendation systems. These are the ones that are most popular in the literature, where you're optimizing for customer engagement. So things like clicks and purchases. And I'll talk about how we do these at Wayfair. Then I'm going to introduce some of the competing business objectives that we are considering that might be in conflict with what you will end up doing in the context of a traditional recommendation system. In order to discuss this, I'm also going to introduce some concepts from multi-objective optimization, including the concept of Pareto efficiency, and I'll talk about some modeling strategies from the literature and what we're doing at Wayfair. So Wayfair is an e-commerce site focused on home. So that includes furniture, home decorations, all that stuff. And the home category has some specific challenges when you shop online. And so here are some of the problems in this space that we try to address. First of all, is just having confidence when you buy. So when you buy things online, you cannot touch or feel products. Customers typically require greater comfort and advice on the item they are buying, especially for these kinds of larger purchases that you'll tend to make for your home. Visualizing products is very, very important. So just like in the fashion space, the home goods space is very visual. And so understanding how a sofa or a dining table will look like in the context of a shopper's home is also important to the business decision. Number three, it can also be difficult for consumers to describe what they're looking for. And as opposed to in the fashion world, brands are not as well known as they are over there. So customers might need a little extra help in terms of shopping for what they're looking for. And then a big one that's different here is for customer service and delivery. The home space is characterized by very heavy and bulky and damage-prone items. Delivery speed can be slow, so there are reasons to try to reduce that, to reduce the chance of damage. So all of these considerations feed into how we recommend products to customers to try to help them find the right product at the right time. So there are several different ways that we show products to customers. The first way is with what I'm calling a product grid. So this is basically just a list of products, and we just arrange it into this kind of grid formation. And we do this several different places on the site. So first of all, search. So there's a prominent search bar at the top of the site. If you enter in what you're looking for, we'll return to you a grid of products that we think best matches what you're looking for. Also, there's browse. So we have a list of predefined categories in our taxonomy, and you can click through those categories to try to find what you're looking for that way. And that also ends up leading you to lists of products in a grid. And then we'll also tend to have sales and special deals that also will be lists of products that we're servicing to customers. And as you'll see, there'll be filters on the side that you can use to help refine down what you're looking for. We also show the customer things called carousels. These are also lists of products, but in a somewhat different context. So in the product grid context, we're showing customers products just in relation to the customer themselves. But when you go on a product detail page, you might see a carousel of products that's not just related to that customer, but also related to the product, the seed product that they're looking at. So, for example, if you're on the product detail page for a lamp, we might show you these other lamps that you might like. So that's the first row of products here. So that's what you might call substitutable products. But then we also might show you products that are complementary. So this could be for cross-sell. So that's why we show frequently bought together. So that's the second list of products, is these are things that we think would go well with the specific product that you're looking at. So as you can see, there are a lot of different contexts in which Wayfair is showing our customers lists of products. And these products are ranked in a very specific way that we're using that ranking to satisfy different business objectives. So we have a few different ways that we do this. The first is just, what do we do if we don't know anything about the customer? So this is basically the cold start problem. We don't have any information about your personal style or what you're looking for. So we're going to rank things for you based on the probability we think you have of buying it. So how do we know which products are best? We have millions of products. We don't know much about most of them. So what we do is we try them all systematically to see how well they perform. So we call this exploration and exploitation, and it works in an iterative process. So for example, if we have a new product that we haven't put in front of customers much before, what we'll do is we'll move it around in the rankings, and we'll see how well it performs at different places in the rankings. And we'll use this information to inform what we think its average conversion rate will be. Also, if we have a product that has already been around for a while, it's been moved around the rankings, we've gotten a lot of data on it, we'll tend to have a pretty good idea on how well that product performs. And then we can exploit that information to get more sales. So in this chart here is just showing kind of this iterative process we're going through, where we generate a ranking of products that we show someone, and then we are collecting feedback from customers. And this is based on clicks and orders and how they're interacting with our list. And then we adjust our belief on what's the real true conversion rate of these products. And you keep leveraging that information to keep ranking in a way that we think is going to improve sales the most. But what if we have information about the customer? Then we want to personalize our ranking. So whereas the previous ranking was based just on what we think an average customer is more likely to buy, this is a ranking based on what we think you specifically are more likely to buy, based on what we know about you, based on your previous activity on our site. So for example, if we know that you've previously looked at this particular rug, that gives us some information about your style, about what you're looking for. And so instead of just showing you the default rankings, we're going to re-rank those based on what we think you personally are more likely to buy. And that ranking is done with a deep learning model. That model takes in information both about the customer and their past behavior, and then also the information about the products. So between these different models, these different ways of ranking products, we are trying to figure out what to show customers in a way that increases customer engagement. So like most typical recommender systems, we're trying to optimize for things like clicks and purchases. And that's great, but there are also other competing business objectives that we would like to take into consideration as well. So for the Wayfair business, these include things like the margin. So how much of the cost do we keep? The shipping distance and cost. Like I mentioned before, shipping these big bulky items can be difficult. And then also there can be supplier incentives. So we have all these suppliers that are providing things on our site, and maybe we want to incentivize them to give us better margins or to place more of their items in warehouses in different locations. So there are a lot of different business objectives here that are not directly folded in to the recommendation systems I just described, which are optimizing for clicks and purchases. So ideally, we would like to take all of these objectives into account when we're ranking products. So that makes this a multi-objective optimization problem. There's no one overarching objective that we can optimize for. We have a bunch of different objectives, and some of them compete with each other. So here's an example just to illustrate what I'm talking about. So on the Wayfair site, we sell ceramic owls. And let's say we have product A and product B. So these are similar kinds of products. They're both stoneware owl figurine sets. They have somewhat different prices, but the thing I really want to point out here is that they have different margins. So the amount of money that Wayfair gets to take home from the product A is lower than the money that we get to take home from product B. So would it be possible for us to, quote, nudge more of our customers towards product B? What if product A is just something that has a higher conversion rate, though? What if product A is the thing that we would be ranking first if all we cared about was conversion rate? Is there a way that we can nudge more of our customers towards product B without losing any of them or losing our ability to identify really popular products? So this brings me to the concept of Pareto efficiency. So Pareto efficiency is related to when you have multiple objectives that are competing with each other. So Pareto efficiency or Pareto optimality is a situation where no preference criterion can be better off without making at least one other preference criterion worse off. So it's a way of describing when you have these competing preferences, how do you figure out whether or not you're in an optimal solution or not? Usually you're in an optimal solution where you can't make one thing better without making other things worse. So the following concepts are closely related. So if you're in an initial situation, a Pareto improvement is a new situation where some things get better and nothing gets worse. So that's an obvious win. You always want to step in that direction. That's the equivalent of starting at one of these gray circles in this graph, like K or N, and you're moving up to the red line, which is the Pareto efficiency line. So you always want to make those improvements. And a situation is called Pareto dominated if there exists a possible Pareto improvement. So you don't want to end up in a Pareto dominated state. And then a situation is called Pareto optimal or Pareto efficient if no change can lead to improved satisfaction for some agent without another agent losing. So that just means you're in a Pareto optimal situation when you can't make one objective better without making another one worse. So the Pareto front here is a set of all the Pareto efficient situations. So that's this red line here. That's all these red circles are situations where you can't make one thing better without making another thing worse. And all the gray dots are where you can make one thing better without making anything else worse. So you want to be on the red line. So given this, there are lots of different recommendation strategies that you can take that take into account the different objectives, but they all have different trade-offs. The simplest thing that you can do is what's called a greedy re-ranking. So you can just say, let's take the traditional recommendation system approach and then just take the top of that list and re-rank it based on a business metric that you care about. So an example here could be margin, as we had in our owl example. So let's say someone's shopping for owls. We rank all of our owls according to what we think would have the highest conversion rate. And then we just say, let's take the top 10 and just re-rank them based on margin, just to make sure that the highest margin products are at the top. This can be a good strategy if you know that the top 10 are all really, really good. And if, especially if they're what we might call substitutable with one another. So if someone doesn't really care if something's in the number 1 or number 10 spot, it probably won't affect things much to move the ranking around in a way that gives you more margin. So that's the simplest thing you can do. Another thing you can do is have separate component models for the various high-level KPIs you're interested in, and then combine them together with a linear combination. So there's lots of examples of this in the literature. That linear combination of KPIs is something that you'll have to tune by hand. So for example, 2 of the KPIs that you can balance against each other can be the margin that you get from the products and the conversion rate. that you'll get from them. And you might want to balance the two of those factors with some weighting factor that you might determine either offline or using online experimentation. So that's like the next level of complexity. Going beyond an even bigger level of complexity is trying to fold everything into one model. So there are several examples of this in the literature where you can build a ranking model where the cost function itself is a weighted sum of objectives. Then you'll have a training process that optimizes the model weights itself and the weights of the cost function at the same time. So the idea here is that as you're optimizing the weights of the deep learning model itself, the cost function is also optimizing such that it's finding Pareto efficient solutions. So here's the initial formulation of what we've been doing at Wayfair. It's a balance of conversion and margin. And this is heavily oversimplified, but in the high level architecture, we have these different ingredients going into what we're calling an optimizer model. So the ingredients are, on one hand, the popularity metrics. So these are things that we get from the models that I described earlier. So there's, on one hand, the default ranking, as we called it, where we're predicting what the conversion rate of products will be on average with our customer base. And then we also have a personalization model where we're figuring out for any given customer, how popular do we think that product will be with that customer. So you have those things on one side, and then the other side, you have all the business metrics that you care about. I know I've mentioned margin a lot here, but there are going to be other business metrics that we care about. For example, as I've mentioned, shipping distance and shipping cost is another big factor for us that we'd like to minimize. So this optimizer model is taking in all the popularity estimates and the business metrics. We're finding this optimal trade-off, and we're trying to find this red line here. We're trying to find the Pareto frontier. So the optimizer's job is to find an optimal trade-off between popularity estimates from upstream models and the margin data. And we wanted to start small and simple and then expand from there. So the initial formulation of this problem is, can we maximize the margin without hurting the conversion rate? So this is trying to bring ourselves onto the Pareto efficiency front. We're trying to not hurt conversion rate based on what we saw optimally, but we're still trying to maximize the margin given that constraint. So ideally, we would train one model that takes in everything we know about all the products and outputs one score that can automatically optimize for all of the competing objectives. However, in practice, this is actually really difficult and probably impossible. And that's because there's typically no one KPI to optimize for. Even if you find that Pareto frontier where you're Pareto optimal, you're still going to need to determine where to live along here. So if you look at this red line here, the idea is you can find that line, but ultimately figuring out where you live on that line requires some level of human judgment about what's most important to your business. So what else can we do to help ourselves move in this direction? So the first one is to define and track measurable KPIs that are proxies for what ultimately we're caring about in this problem. And that's the profit we get from our customers over their lifetimes. Ultimately, what we care about with these profit-aware recommendation systems is maximizing the amount of profit we get on the long term. And the way we maximize that profit is by showing customers things that they want to purchase, showing them things that are very relevant, but then also making sure that we have a decent enough margin, making sure that we're not spending all our money on shipping costs, making sure that all of those business objectives are also satisfied. And when you start folding in things like supplier incentives, keeping the suppliers happy, you end up with something that is kind of impossible to measure, kind of impossible to model. And that's this concept of customer lifetime profit. But what we are doing, and what I recommend you all do, is come up with proxies for customer lifetime profit that are actually measurable things. It could just be like profit over time, but also what else are you interested in? Are you interested in repeat purchases? Are you interested in reactivating? Think about what metrics are the most important to your business, not just on the consumer side, but also if you, like us, have suppliers. On the supplier side, what are the metrics of success? Does it depend on suppliers? Do they give you CSAT scores, or do they, do you measure how often they re-sign their contracts, things like that? So think about what KPIs are really important. Another really important thing for this kind of problem is to invest in offline simulation capabilities. So we want to determine the effects of pulling different business levers, and online experimentation is the gold standard for figuring out what's going on, but they can be very expensive. So if you want to see if like a certain strategy for a certain supplier or a certain way of prioritizing different shipping costs, if you want to figure out if that's going to be worthwhile for your business, it's good to have some kind of way to use your historical data to do a simulation to figure out, is that even a thing that we should even try in the first place? So investing in offline simulation capabilities is the second thing. But then also online experiments for recommender systems typically only follow them for the few weeks time frame and not that much longer. So another thing that we can do is to follow these experiments beyond the typical first few weeks time frame and invest in modeling longer term customer behavior. And the more you can invest in modeling longer term customer behavior on your site as a function of all the ways that you rank your products, then that can feed back into your ability to do robust offline simulations.